In this video, we're going to take a look at a couple of examples of solving quadratic equations using square roots. So the first thing that I want to talk about here is the idea of inverse operations. Because anytime we're solving any equation of any type, what we use are opposite operations to sort of undo operations until we get the variable of interest by itself. So for example, whenever we see addition, we can undo that with its inverse operation, which is subtraction. Whenever we see multiplication, we can undo that with its inverse operation, which is division. And we're going to look at some equations today that have a sort of a new operation, a square, and the inverse operation of that is a square root. So as long as you're solving an equation by keeping in mind the inverse operations that you need to use, you should be in good shape. Now this method we're going to talk about is using square roots to solve quadratic equations. Quadratic, of course, meaning that we have the highest power and that is a square. And this can be used to solve some quadratic equations, but not all. These can be used to solve quadratic equations where there aren't any variables outside of whatever is being squared. So, like for example, if we're going to take a look at solving something like 2x squared plus 4 is equal to 18. That equation has the variable being squared, but there aren't any other variables around it. So we're going to be able to solve that using a square root. We're also going to be able to solve equations like this, where we have a quantity being squared. So the quantity x plus 1 squared minus 4 equals 12. The only variable we see is still within this square. So we're going to be able to use this equation, or this method, to solve that equation. Alright, so let's take a look at each one. This first one here on the left, I want to get this x by itself. I want to do inverse operations to get rid of this 2, this square, this plus 4. So I got to think about what I can do. Well, the first thing I know I can get rid of right away is this plus 4 that's hanging out there on the right. I'm going to do the inverse of adding 4, which is subtracting 4. So 2x squared is what I'm left with on the left. 18 minus 4, it's going to give us 14. And now I have to get rid of this 2 and this square. So the two operations we have are multiplication and a square. Now if I took the square root, I would have to do that to the whole side, and then I'd have this radical 2 under there, and I don't want to do that. So I want to get rid of that 2 first by dividing both sides by 2, and that's going to leave me x squared is equal to 7. So what this is saying is, what number, when I square it, gives me 7? Well, inverse operation of the square is to take a square root. On the left side, the square root and the square are inverses, so they cancel each other out. On the right side, we have the square root of 7, but that's not the only number that you could square to get 7. Positive square root of 7 and negative square root of 7 could both be squared to get 7. Now, if you wanted to approximate this, we would have to figure out what the square root of 7 is. So let's take a look here. I'm going to take a look. Square root of 7 is about 2.65. So x could equal positive or negative 2.65. Now I want to go ahead and check this answer and see if it works or not. So I'm going to take that solution, which is rounded right now, so I might not get the exact thing. So I'm going to plug that into here. So I have 2 times 2.65 squared plus 4. I should get just about 18. And I did. The only difference here is because of some rounding. Now let's take a look at negative 2.65. So 2 times negative 2.65 squared plus 4 is the exact same thing. The only reason we're a little off is because of rounding. This first answer that leaves the radical as it is, or simplifies it, is called an exact answer. And this answer that we rounded is called approximate. And it depends on the setting that you have, the instructions of the problem, of which one you should go for. So let's take a look at this second example, and I have quantity x plus 1 squared minus 4 is equal to 12. And I want to think about inverse operations, and I see this minus 4 hanging out there on the right, so I'm going to go ahead and get rid of that right away, which will leave me with this quantity x plus 1 squared is equal to 16. Now I want to get rid of this plus 1 and this square. I can't do anything with this plus 1 right now because it's trapped in the quantity. I have to get rid of that square before I can do anything to that plus 1. So I need to do the inverse here and take the square root. On the left, the square root and the square cancel, and I have x plus 1. On the right, anytime you have undone a square, you need plus minus. Square root of 16 is 4, because positive 4 squared is 16, and negative 4 squared is 16. Now I can get rid of that plus 1 because I've freed it, and x is equal to, well, it's actually going to be equal to two different numbers. This plus minus symbol really describes two numbers. This is saying that we have positive 4 on the right, and we also have negative 4 on the right. It just condenses them into one symbol. So I'm taking positive 4 minus 1 and getting 3, and I'm taking negative 4 minus 1 and getting negative 5. So I've got these two solutions, and let's go ahead and check that and make sure that they work. So I'm going to take this original equation, look at it just as it is, but instead of that x, I'm going to substitute 3 and 5. So in parentheses, I have 3 plus 1 squared minus 4. It should give me 12, and it does. Checking negative 5 plus 1 quantity squared minus 4 is also 12. So both of those solutions work. I want to point out just real quick a type of an equation that could not be solved using this method. So if you have a quadratic equation like x squared plus 4x is equal to 12, there are ways to solve this equation, but you can't solve it using a square root because there's a variable other than the x squared. This is not being squared. If I tried to take the square root, I'd have to take the square root of the whole side, and there's no way to simplify that, so there's nothing I can do with that square root. We're going to learn a different way to solve this type of equation in a different video. What you should be able to do from this one are take an equation that has one thing being squared, no other variables in there, and solve that using square roots.